Good morning, dear students. My name is Ferhan Mazher, and today is 13th of February 2022. Right now, I am with the ninth Cambridge class, and the subject we are studying is Mathematics Syllabus D. This is Cambridge O Levels Mathematics, and the code of the subject is 4024. We are working on the syllabus, and today we have selected the book D3. The name of the book is New Syllabus Mathematics 7th edition, third book. And we are working on the chapter number 12, and we are going to do exercise 12A. This is the second video on this exercise. In the first video, which I have already uploaded in my YouTube channel, we have done from question number 1 to question number 10 of the exercise 12A. Today, in this video, in this session, we are going to attempt question number 11, 12, 13, 14, and 15, and this exercise will be completed. This exercise is about the area of the similar and the congruent triangles. So let's start this exercise, and I hope that this will help you. So, my dear students, we are on exercise 12A from the D3 book of the mathematics, and we are going to attempt question number 11. So, on your screen, you can see that the question number 11 is showing up. He says in the figure, MN is parallel to the QR. If the areas of the triangle PMN and the trapezium MQR and R in the ratio 9:16, find the ratio of the MN to the QR. So you can see here we have a triangle PQR and the PMN. These sides of these two triangles, they are parallel to each other, and we know that when this diagram is shown, this angle and this angle is same because they are corresponding angles. This angle and this angle is same, they are corresponding angle. This angle is common. So this small triangle and this big triangle, they are similar to each other. So the ratio of their areas will be equals to the ratio of their sides and its square. So square of the ratio of their sides, I mean. So I know the area of this, that's 9, and the area of this trapezium is 16. So the area of this big triangle will be 9 plus 16, and that will be 25. So once you know the area of the small triangle is 9, area of the big triangle is 25, because both these triangles are similar to each other, very easily I can find the MN ratio QR, because they are the side, this is the side of the small triangle, this is the side of the big triangle. Let me show you my solution. So here we go. So we are going to attempt question number 11 to question number. So it is given that the triangle PMN ratio, the MQRN, the areas. This is the ratio of the areas, 9:16. So this small triangle is 9, this trapezium is 16. So the big triangle will be 9 plus 16, 25. So here you can see the triangle PMN ratio, triangle PQR will be 9 ratio. This will be 16 plus 9, and that will be 25. And we know because this small triangle PMN and the big triangle PQR, because they are similar to each other, so the ratio of their areas will be equals to the square of the ratio of their sides. So MN is the side of the small triangle and the QR is the side of the big triangle. So their ratio and square of it will be equals to the ratio of the areas. So 9 by 25 will be equals to the MN by QR whole square. So I will take square root on both the sides. So you can see here I have taken the square root. So the MN ratio QR will be equals to 3 ratio 5. So my dear students, this is question 11 of the exercise 12A D3 book. Okay, so I hope that you have understood this, and let's go to the next part. So the next question coming up on your screen, it is question number 12. It says in the figure, BCD is a straight line and BA is parallel to the DE. Angle ABC is 90 degree and the ACB angle is equals to the ECD. So this angle is 90. This angle here and this angle is equals to each other. This is given in the question. The areas of the triangle ABC and the CDE are 25 centimeters square and 64 centimeters square respectively. Given further that CD is 4.5, this side is 4.5, longer than the BC. So if it is X, this is X plus 4.5. Find the length of the BC. So we want to find the BC length. Very simple and a straightforward question, because these two are parallel to each other. So if this angle is 90, this angle will be its supplement. So it's 90, this will be also 90. This angle and this angle is same, this angle and this angle is same. This is same because it is given, this angle and this angle, because they are allied angles. So if this is 90, this will be 180 minus 9, it will be also 90. So two angles in these two triangles are same. So these two triangles are similar to each other. Okay. So if these two triangles are similar to each other, then the ratio of their areas, A1 by A2, will be equals to the ratio of their sides. So the ABC by the triangle CDE area equals to BC by BC plus 4.5. CD is basically BC plus 4.5. It is said here somewhere. Yeah, the CD is 4.5 centimeter longer than the BC. So very easily you can find this. Let me show you the methodology, how this is done. Here we go. So I know that the area of the ABC is 25 centimeters square. It is given. It is given in the question. The area of the CDE is 64 centimeters square. It is also given. It is also given that the CD is 4.5 plus BC, and the BC is question. The angle ABC is 90. It is given. CDE angle. This angle will be also 90. Why? Because this angle and this angle, they are allied to each. Because you can see these parallel lines. So these two angles, they are allied to each other. So the CDE angle will be 180 minus 90, and that will be 90. So the ACB is equals to the ECD. It was given in the question. This angle, they are equal. So I can say that the triangle ABC is similar to the triangle ECD. Now, so once you know that the triangle ABC is similar to the triangle ECD, the reason is angle similarity test. Now I can say that the triangle area of the triangle ABC divided by the area of the triangle ECD is equals to BC square divided by CD square. And the value of the area of the ABC triangle is 25, area of the triangle ECD is 64, equals to BC. And we know that the CD was 4.5 plus the BC. And then we have a square over it, and we take square root on both the sides. So you will have 5 by 8 equals to BC divided by 4.5 plus BC. So cross multiply here. So you will have 2.5 plus 5 BC equals to 8 BC. So you will have 2.5 equals to 3 BC. So BC is equal to 2.5 divided by 3. And the BC value will be 7.5 centimeters. So this is how you do question number 12. I hope you understand this question. So my dear student, that was the question number 12 from the exercise 12, from the exercise 12A. So, so the next question coming up on your screen from the exercise 12A is question number 13. In the figure, XY is parallel to RS. XY is equals to 2 centimeter and the QR is 6 centimeter and the RS is equals to 4 centimeter. Given that the area of the triangle PXY is 10 centimeter, find the area of the triangle PRS. So they want you to find out the area of the PRS. If you look at the PXY and the PRS, they are these sides, they are parallel to each other. So this small triangle and this big triangle, they will be similar to each other. And if they are similar to each other, then the ratio of their areas will be equals to the square of the ratio of their sides. So let me do the first part, and here we go. So the question number 13, the triangle PXY equals to 10 centimeters square. The area of the triangle PRS is question. We know that both these triangles are similar to each other because their third sides are parallel to each other. So the triangle PXY divided by the triangle PRS is equals to the ratio, the square of the ratio of their sides. So XY divided by RS whole square. So the area of the triangle PXY is 10. The triangle PRS, I want to find out its area, equals to XY is 2 centimeter and the RS is 4 centimeter, and we have a whole square on it. So 10 by the triangle PRS is equals to 2 and 1. As you know, this 2 and 4, they can be cancelled. 2 and 4, 1 by 2, and then you take the square. 1 square is 1, 2 square will be 4, then cross multiply. So the triangle PRS, its area will be 40 centimeter square. 40 centimeter square. The second part of the question number 13 is he wants you to find out the area of the triangle PQR. PQR. Okay, so this is a new concept. Try to understand. You know that I know the area of this whole triangle. This is the base for both the triangles. So this triangle and this whole triangle, they have this line as their base, and their third vertex is common. If this happens, then you can say that the areas, the ratio of the areas will be equals to the ratio of their bases. So try to understand once again. You see, we are talking about the triangle PQR, its area I want to know. The triangle PRS, its area I already know is 40 centimeters square. In these two triangles, there is a special case. They have the same baseline. You can see I have colored the bases. So the baseline for both the triangles is same. You can see their third vertex for both the triangles is the common point. So if this happens, the area of these triangles who are in this case is equals to the ratio of their bases. We don't take square on it. If this is the case, then both the triangles involved, the ratio of their areas is equals to the ratio of their bases. And I know that the base is here. This is 4, this is 6. It is given in the question. So the triangle PQR divided by the triangle PRS will be equals to the base 1 by base 2. Triangle PQR, I want to know its area, and the PRS area I know is 40 is equals to 6 by 4, cross multiply. So the triangle PQR will be equals to 6 by 4 multiply 40. So the triangle PQR will be equals to 60 centimeter square. So that's the question number 13B part. I hope you have understood. Question number 14 is showing up on your screen in the figure. AC is parallel. So they are talking about this. The AC is parallel to the QP. AR, this is 4 centimeter. The QA is 3. DQ is 7. And the PD is 4. The first question is find the length of the BC. They want us to find the length of the BC. The methodology is very simple. First of all, I take this triangle. You see this triangle? This and this big triangle, they are similar to each other. So I will find the length of the AB. Then I will consider the big triangle. This triangle and this big one will be similar to each other. From there, I will find the length of the AC. Then from the AC, I will subtract the AB, and I will find BC. So let me show you my solution. So hopefully you will be able to understand this, how this is done. Okay. So the question of 14 is first part. The basic question is what is the value of the BC? So first of all, I will take the triangle ABR and the QDR. And from here, I will try to find out what is the length. Sorry, here we have taken the big ones, the big triangle, and the big triangle is ACR and the QPR. From here, I will find the side AC. So the AR by the QR will be equals to AC by the QP. And you know the AR is 4 and the QR is 7. The AC is question and the QP is 11. So from here I know that the AC will be 44 by 7. So once I know the value of the AC, then I will take these two triangles ABR and the QDR. I will take this AR by the QR equals to AB by the QD. Let me show you. Okay, so here we are doing that. AR by the QR will be equals to AB by the QD. So 4 by 7 will be equals to AB by 7. So AB will be 4 by 7 into 7, so equals to 4. Once you know the value of the AB, now I know the value of the AC and I know the AB value. From the AC value, I will subtract the value of the AB and I will get the value of the BC. So here we go. BC will be equals to AC minus AB, and that will be 44 by 7 minus 4. I will take the LCM. So 44 minus 28, the whole thing divided by 7 equals to 16 by 7. That's 2 whole 2 by 7. So that is how you do the question number 14 and its first part. And let's go and check what's the next part. And we will do the next part. And the next part is the ratio of the areas of the triangle ARB, ARB, and the BRC. Okay, so these two triangles, they are not similar to each other. Their baseline is same and their third vertex is common. So in this case, the area, the ratio of the areas is equals to the ratio of the bases. And this is that special case which came in the question number 13, and now that is in the question number 14 also. So let me show you. Okay, so we are talking about these two triangles. The triangle ARB by the triangle BRC will be equals to the base 1 by base 2, because I know their bases and their baseline is same and their third vertex is common. So in this case, both the triangles are not similar to each other, but the ratio of their areas will be equals to the ratio of their bases. So the B1 is 4 and the B2 will be 16 by 7. So 4 multiplied 16 by 7, and that will be 7 by 4. So the area of the triangle ARB ratio area of the triangle BRC will be 7 ratio 4. 7 ratio 4. Hopefully you understand. Okay, the third part is the ratio of the areas of the BRC, BRC, and the triangle B and the trapezium. They're talking about the trapezium A, B, D, Q. So they want you to find the ratio of this with this. Okay, so it's kind of, it's a little heavy question. So let me show you how this is done. Okay, so the basically I want to know what is the ratio of the area of the triangle BRC to the ABDQ, which is a trapezium. First of all, I will find the triangle ARB by the triangle RQD, and that will be because they both the triangles are similar. If you look at, if you are looking at the diagram, so there one side is 4, the other side is 7, so it will be 4 by 7 square. So the triangle ARB by the triangle RQD will be 16 by 49. So the triangle ARB divided by, if you double that, the RQD, it will become ABDQ. If you, sorry, I said double it. If you subtract both these triangles, you will have the that trapezium. So from the RQD, if you subtract the triangle ARB, the remaining area will be ABDQ, that trapezium. So 16 by 49 minus 16, so that 33. So I know that the triangle ARB by the trapezium ABDQ, that will be 16 by 33. Another thing I know, I already know the ratio of the triangle BRC with the triangle ARB. So I will write here the triangle BRC by the triangle ARB into the a triangle ARB by the trapezium ABDQ. Do you know this and this will be cancelled? I know this value, that's 4 by 7. I know this value, that's 16 by 33. And this will be cancelled. So on the left side, you are left with the triangle BRC divided by the ABDQ, and that will be 64 by 231. So this is how you do question number 14, third part. It's a little heavy question for the grade 9, but try to learn it. Okay. So here we go. So on your screen, and now the question number 15 is showing in the figure. The PQ is parallel to the AC. The PQ is parallel to the AC. Given that the BQ is 4 centimeter and the BC is 10, and the area of the triangle BPQ is 8 centimeters square, find the area of the triangle ABC. Very easy. You can see, let me show you. I know the area of this triangle, and he wants me to find out the area of this big full triangle ABC. Because they are this side, because this side is similar. So they are similar, parallel to each other. The sides are parallel to each other. So these two triangles, they are similar to each other. The BPQ and the BAC, they are similar to each other. I know the area of this, and I want to know the area of this full triangle. I know this side of the small triangle, and I know the side of the big triangle. So very easily we can find that triangle's area. Okay, so the triangle BPQ, its area is 8 centimeters square. The triangle ABC, its area is question. The triangle ABC by the triangle PBQ will be the BC divided by the BQ whole square, because they are similar. So the ratio of their areas is equals to the ratio, the square of the ratio of their sides. So the triangle ABC divided by the area of the PBQ, I know, is 8, is equals to BC is 10 and the BQ is 4 whole square. So ABC triangle will be equals to 8 multiply 100 divided by 16. So the triangle ABC area will be 50 centimeter square. So now I know the area of the triangle ABC. It will be 50 centimeter square. That's how you will do question number 15 and its first part. Second part is he wants you to find out the area of the triangle PQC. He wants you to find out PQ and C. So join the P with the C. So these two triangles, they will be not similar to each other, but their baseline will be same and their third vertex will be the P. So in this case, you know the area of the ratio of the areas is equals to the ratio of their bases, and we know their bases. So very easily I will be able to find the area of the triangle PQC. So let me show you my solution. Okay, here we go. So if you want to find out the area of the triangle PQC, here you can see I have shown that the triangle PBQ and the triangle PQC area I want to find out. The area of the triangle PBQ I already know is 8. These two triangles, I have shown it with the colors that their baseline is same and their third vertex is the same point, P. So in this case, the area of this triangle and the area of this triangle will be equals to the ratio of their bases. That will be 4:6. So the triangle PQC divided by the triangle PBQ will be equals to QC divided by the BQ. Triangle PQC will be divided by the 8. I know the area of this triangle. It's 8 equals to the QC is 6 and the BQ is 4. So cross multiply here, and then you will have the triangle PQC will be equals to 6 by 4 multiply 8, and the triangle PQC is 12 centimeters square. I hope you understand this, and I hope you understand this case in which the two triangles have the same baseline and their third vertex is the same point. And in this case, the ratio of their areas is equals to the ratio of their bases. So this is how you will do the question number 15. It's the second part. Okay, so let's move to the third part. He wants you to find out the area of the triangle AQC. They want you to find out the area of the triangle AQC. You can see the AQC and the ABC, they have the same baseline. Their third vertex is common. We know their bases, so very easily I can find the area of the triangle AQC. So let me show you. Okay, now they want you to find out the area of the triangle AQC, and you know that the AQC and the full ABC triangle, they have the same baseline and their third vertex is same A point. So the ratio of their areas will be equals to the ratio of their bases. So the triangle AQC divided by the triangle ABQ equals to QC divided by BQ. Okay, so the a triangle AQC divided by the triangle ABC will be equals to, sorry, I think I made a mistake here. Here the triangle AQC divided by the triangle ABC will be QC divided by BC. Just ignore this statement, okay? QC divided by BC. So the triangle AQC will be the area of the triangle ABC we just calculated in the previous part, that's 50. And the QC, the base of this triangle is 6. The base of this whole triangle is 10. Just cross multiply triangle AQC will be 6 by 10 into 50. So the triangle AQC will be 30 centimeters square. Here again, we have used that case in which this triangle and this full triangle, they have the same baseline. This colored line is their baseline, and they have third vertex common. So the ratio of their areas is equals to the ratio of their bases. Just ignore, I think just ignore. Okay, I just want to say, just ignore these two lines. Okay. So, my dear students, we are done with this exercise, and I hope that this video will help you. By this question number 15, we have reached the end of this exercise. I hope that this video will be helpful to you. It will help you to understand the concepts which were taught in the exercise 12A, and they will improve your mathematical skills. So if you think that this video is helping you, please do share the link of this video onto your Facebook and onto your Instagram and onto your Twitter accounts. Share the link of these videos through the WhatsApp with your class fellows, with your teachers, and with your cousins in all levels. So thank you very much, everybody. It's a great blessing for me to teach you online. So thank you very much. Have a good day, and God bless you all.